Hello, everybody, and big thanks to Carl. I think he already said most of the things that I am about to say theoretically, but I'm more practical guy, so I'm hoping to show you some real practical use cases where you could actually use machine learning today. And the main idea is that you don't have to have hundreds of thousands of euros ready. You can pilot your idea rather quickly, whatever it is, unless it's not very common specifically to your business case, but it's a rather general idea. I'm a bit younger in this field, so since 2006 I have been working in IT. When I first started, the main idea was to build individual systems. Everybody were building their own systems. These weren't really tightly integrated with one another. As the years go by, the main benefit is starting to emerge from integrating different solutions. So, for example, let's say that I have an electric car and I live near the city in the suburbs. And through machine learning, the algorithm knows that every Tuesday I have a training in the city center. So taking the distance that I go there all the time, calculates how much battery I have in my car, and realizes that I don't have enough charge. If I don't put the car to charger, then I won't make it. So things like that improve our everyday life, but these are small, different components brought together by integrating different solutions. And this gives us more and more value. And AI, as mentioned before, is pretty much a tool, a hammer for other business ideas. So we cannot take it as one-stop shop or single solution or silver bullet. It's just something that helps us to make some decisions or to guide us in our decision making. Some AI integration possibilities that are readily available more or less as a black box, basically. This means that we can take a solution such as OpenCV. It's a computer vision library that can do some OCR or computer vision implementations without us even needing the vast amount of data to train some algorithms. So it's a good place to start with some ideas. Would this work with my project? There's also Google. The cloud AI has vast amounts of different implementations of machine learning networks. So you can go there and find out whether any of these, such as face recognition, object detection, speech, can benefit to your business. And you can try them out, in many cases, right there in this page. So if it gives you desirable results, you know that, yes, there's a possibility I could use this in my project. Maybe I will have to train my own model, but the main idea would be that, do I have enough data? Is my data valid enough to use a machine learning model? Teachable machine, this is something I will show you later on. So on stage, we will train an algorithm and use it. So don't go anywhere. It's not very accurate because it doesn't have that much input data, but you will get the understanding of where we have come with these actual implementations of different general machine learning algorithms. Some more possible integrating partners or library providers, Microsoft, of course, many cloud-based AI solutions. Yes, they are built by requests, but the cost of one request is like 1,000th of a cent or something like that. So if you want to try it out, it's free, right there in the web page. but they offer, and they continuously improve. What is great here is that if you are building your own network, your own model, then you will need the actual hardware, the servers with the GPUs. And if your project doesn't work, or the machine learning algorithms don't provide you the data that you need, then what will you do with the hardware? So great place to start. And there's a fun place called Algorithmia. It's a free marketplace, or open marketplace for everybody to upload their own model or use someone else's model by their own credit system. There's a bunch of, let's say, unusable stuff, or I don't know why you would need it, but then again, there's many meaningful algorithms there. So you can go and check whether someone has already trained the system. For example, the name, card, address, or contact info detector. The model understands where usually the name is, where the contact info usually resides, and extracts the data and gives it back to you in a structurized format. Just a small sample. Sentiment analysis, you can understand what's the content. Is it positive or negative? Colorizer, it's a fun tool. I will just show it because maybe it will open up some ideas for you. And the interesting area, heat map, it's another thing that you might combine with next algorithms, because it alone gives you not that much of a value, but if you combine it, for example, with the image cropping tool, then you will see the benefit. I will show it just in a second. But first, let's try to beat the machine with the sentiment analysis. So I have some quotes here. Some of them are from Twitter, so they might be not so positive. But others are from, let's say, Wikipedia. So what I would like you to do is to understand which of these is the most positive sentence, and working our way down to the most negative sentence. So which of you think that, or what number could the most positive sentence be? 1, 2, 3, 4, 5? 1. Okay, I heard more 4s. Let's take 4 is the first one, right? So the second one, this could be then the 1, right? Working our way down. Now we should be in the neutral zone someplace. We have 2, 3, or 5. 2. I heard 2. Let's take 2, right? Now, a bit negative. 5, and the most negative being the third one, right? All right, let's see what the machine thought. So this is the most positive because of all these exclamation marks, best, OMG, words that indicate it's being in a good context. But if we would add quote marks around the best sentence, the machine wouldn't catch that. So actually, it could mean the opposite. But otherwise, your prediction was correct, so to say, or let's say the machine was correct. Although this here, the fifth one, isn't actually that negative. It's quite kind of a neutral sentence, but due to having the words bias, inaccurate, this brings the, let's say, the sentence a bit downwards. So Colorizer, this was I think it was the best black and white picture in 2018. It's an algorithm that finds out or thinks what these colors might have been. So this slide shows you the output of the machine and the actual picture. So it's pretty much the same, but you see that the headband here is not colored, and most likely the input data that they had, people had pictures on their T-shirts. So it's colored here a bit blue as a blob. Moving on to the interesting area heat map. So I had a site some years ago that was rating different beers. And the problem was to understand if you take a picture of a beer bottle, is it already in the system? It can be from any angle, but what I needed was the label, to crop the label out and match it with actual other labels. So from the output of the algorithm, it says that the most interesting part is here, which is correct. So I can use a cropper to crop this part out and get the right results. So maybe you have seen that if you want to put your profile picture on Facebook or whatever, so it takes the body part and then you have to adjust to your face because it doesn't understand what part you might want to expose if you have a rectangular picture, but square is allowed size. Now, these are all fun and games. I would like to show you a proof of concept that we did. So we had to read in car registration data. So this is the regular green card that you get with your car, although it's for trucks. The problem was that the regular OCR wasn't very good understanding these letters and numbers if this scan was in color, because it has all this noise in the paper. And as well, some of the letters are printed on the lines, so it confused the OCR pretty much. And we had different formats, so this is like the European one, or I think it's even not European, but most of the European countries use this, but for example, Poland has a different sort of format for it. So we tried to understand whether machine learning would be helping us here. It's a bit hard to see, but some of these fields, or most of the fields, have light gray boxes, and this is the small print is what it read out. It's not that important that you see, but it read in most of the details, except some of the letters like here, here, here. These they didn't understand, but for us they are clearly visible. This isn't a big problem, but the biggest problem is something like here. So the algorithm thought that this is one big sentence and concatenated it all. And the other one is here. So the field S1 has a value of 2, but the algorithm thought that this is S12 value. With these, we can use some additional filtering methods. We know that in this area, there should be one-digit integer, and this field is S1, so we can extract the S1 or just find out is the integer there. This gave us enough confidence to move on with this sort of OCR, but not even using the Microsoft one. This is Microsoft OCR. But we're trying to build our own network on TensorFlow, teaching with these letters that we find on these registration sheets. And this took less than a week to understand, yes, this is a viable solution, we can move on with this. Or it might have gone the other way, saying that, okay, it's unreadable for machines as well, so we must think of another way. Now, I would like to show you how to teach a machine. So if you would be so nice to cue the screencast. Since I cannot do it on this machine, I just recorded a very fast, quick video. So it's Teachable Machine by Google. You can do different projects here. We are doing an image project called the client detector. It's a machine that understands who is our client and who is not. We don't have much input data, so we have some faces here. We know that these are our clients. We say that the class 1 is client class, for example, and we just add some pictures to the other class and saying that these pictures are from other clients. So it's not maybe a really good use case, so to say, but it illustrates some nice facts here. So we train the model. It takes, on a fast machine, good internet, approximately 5 to 10 seconds. But regarding on input, if you have more input, it will take a bit more time. And then you will be able to validate with some other data that was this model successful. And the good idea here is to, if you have 100% of data, you use 70% as a training model and 30 as a test model, so you understand that the model works. But let's try to see, we have some test cases here, whether these are our clients or not. So what happens here, I don't know if you noticed it, but actually I labeled the first set as clients, but these clients all had something in common. So they were all wearing glasses. And for the machine, this was the common denominator for all of the pictures. So some of these are like false positives. So for example, the Trump picture was a customer or a client, but he didn't have any glasses. But mostly, if we look at the pictures with glasses, the machine says it's a client. So it was my problem that I labeled this classifier as a client, but for machine, it was people with glasses or classes. So you have to be really, really focused on your input data. This is the bias that Karl was talking about, so you might put some bias into the system. And this is where, for example, lots of the law enforcement has failed because of this. Their input data was not generalized or really universal, but they were biased on one side. And this, I hope it plays, is a nice example of the machines. It's a approximately 3 years old girl. And the trainer is trying to show her that she must break this sheet of wood. Is it connected to the internet?
It's connected to the internet, but it's not playing back. Just in a few minutes, maybe play.
Okay, so I just jump to the conclusion, and then we can look at this cute video. So the main idea is that if you have some ideas, if your ideas fall into the category of prediction or classification, then machine learning can help you a lot. And if you look into these big providers, AWS, I didn't mention it, Amazon has also a big set of machines ready for you to try out, even in their own web page. Just upload a photo, upload some data, get the results. So you can understand really, really, really quickly whether my picture is, I don't know, good enough for this, whether my audio file is good enough for the machine to understand what's going on there. And if you see that, yes, there is something, we can move forward, we can add some more money into this proof of concept, then you can go on and try to train your own model or use even more hardware for this solution.
Saluda, párate.
But the main idea there is that we are showing the machine what to do without actually doing it ourselves. And in this sense, the machine learns not the actual action, but what we show them to do. And this is a fun example of the same thing that happens with humans as well.
Se cayó. Dale.
And this can be the case that if we don't know what we want to achieve with this algorithm, then the algorithm doesn't have the answer to us as well. But anyway, this goes on for a bit. My name is Markus, and thank you for being here. I hope you had some great insights, and now we can move on to our next talker who will give some health-based insights regarding AI. Thanks.
But questions? Online? No questions? No? Yeah? But please use mic.
If you give input data, for example, clients' pictures, how or even if it is possible to make learning not take account of the classes factor?
Thank you for a good question. Well, basically, it's at some point it's trial and error, but in other cases, if you would look at the input set of data and you see that there's a common denominator that actually should not be included in this algorithm. For example, you have all men pictures, but actually you don't want to train the system to recognize that, okay, if it's a man, then it's okay. If it's a woman, then it's not okay. So you have to provide, maybe you have to exclude some of your input data just to make it more diverse. So if you have maybe hundreds of pictures with glasses, tens pictures without glasses, then you even out the amount of different, let's say, factors that the system might think that it's relevant to your model. So a bit curating on the data helps a lot. So for example, for law enforcement in the United States, if it happens that at that moment they have more black people in the prison cell and less white people, then it doesn't mean that all the black people are somewhat evil. It just happens out that in this district or in this station, it happens to have this set of data, but it's only a subset of the actual data. So you must curate it a bit to make it more equal in that sense. Because if we take a person who is biased, then it's only one person. And the one person works from 8 to 5 and then goes home and doesn't do any more harm. But the machine learning model is scalable and it works 24 hours all the time, everywhere. So if we train a model to be biased, the impact is enormous. But for one person, it just evens out within the good guys, for example. So did it answer your question? Yeah. Yeah.
Thanks. I have a question about getting the right algorithm for me. Where should I start? Like, if I don't need the algorithm to detect something from the pictures, but I want a specific algorithm for me to do something, where should I start looking for it?
Yeah, okay, so if it's not computer vision where machine learning is great at the moment, if it's prediction, for example, then one place again would be either cloud AI to see whether your data is, let's say, it's computable in a way for the machine to give you some answers. But then moving on, then you would have to go into coding, find out whether TensorFlow is the right framework for your problem using some scikit-learn libraries in Python to predict the data. But then again, if you are doing this yourself, there's two options if it doesn't work. Either you get it wrong or the data is wrong. But you don't know which one of it is. So if you can validate your data on readily trained algorithms, and it can be that the algorithm is good at detecting cats, but it can be really well used to detect dogs as well. But you have to validate it with your data to understand. It is probable, I will invest some time in it, or it's not probable, let's move on. So there is no good answer to you. My first suggestion would be to validate whether trained algorithms by big giants, such as Microsoft or Google, have already provided you, and these give you some insights that, okay, there is something in my data. It's not biased. It's giving me the feedback that I'm expecting it to give. And then you can move on to find out what's the right framework for you, and most likely widespread TensorFlow is something that can handle your data as well, because it actually, I think it doesn't matter that much, but then again, it's specific to a problem.
Any questions from the audience? So I have a question online. So one question from YouTube from Raul. Since a good quality amount of data is the basis of any machine prediction, so in machine prediction, is the owner of the best data set the winner of the game or whatever?
I suppose so, yes, because it's pretty much as goes the same, for example, in the stock market. So if you have really good insights, you have really quality data on what's going to happen, you're the winner, because you will know what's happening most probably in the next step. Yes?
Sorry. You might have the best data in the world, but if your algorithm is wrong, the data quality doesn't matter. Like they're so interact together, I think. Thank you.
Yeah, it's true. You can't have one without another, but you cannot have the greatest model in the world with the bad data. So you have to have the good data to train the model to be the best in the world. But then again, if you have good data and you don't know how to train your model, then you're only halfway there, and somebody might beat you to it. But you have all the, let's say, the prerequisites to be the winner. All right, thanks.